Hello, everyone. Thank you so much for being here, and thank you to Miguel for the kind invitation. I know that doing this type of presentation in an insurance summit, you would certainly view me as a bit of a mad scientist. So hopefully this afternoon, the way that I will try to orient this session is one of focusing more of how to situate generative AI in light of the eras of past, present, and future. And so today I'll kind of walk through how this technology didn't just come up from nowhere. It has come from decades of research. Where we are today, what are the primary concerns, and an eye towards the future. What should we be thinking about, or at least some of the work that our research center has been exploring. So a little bit about me is that I'm the Associate Director at the Stanford Center for Legal Informatics, or we call it Codex. This is a research center that's situated at Stanford Law School, but is actually joint between law and computer science. And so unlike other research centers, we build technology for law. And so starting a little bit about the background of large language models, how did we even arrive here? Obviously, as I mentioned, it didn't come about overnight. You can hear about imagery of artificial intelligence that dates back to the ancient Greeks, but really the idea of neural nets dates only as far back as the 1940s. In this era, the focus was very much on modeling after the brain. Could we actually create a machine brain? The idea was that you would be able to think about ways in which we can mimic the neurological processes that our mind goes through. What are the inputs? How do you weigh the options? And how do you arrive at our outputs? This is a little bit about the historical timeline. Again, if you look at all of these segments, most of them were, again, focused on this question of can we recreate the human brain? And I think this imagery doesn't really stray that far off from today. I think till now we still see little moments of it, and I'll talk a little bit about that. And so this is the basic architecture of a neural network. How many of you in this room have heard of sort of these kinds of terms floating around? Neural nets, deep learning. And so all of this is basically trying to, again, look at how we think about the human mind, but mirror it in a technological process. You have the input layer, you have several layers of these other neural nets in between, and this is where people talk about the black box, and then finally you have an output. But up until then, about 2017 was really a moment of revelation. So how many of you have heard of actually the attention is all you need paper and the rise of the transformer? So not too many, but this is actually quite a seminal paper for the industry because the T in GPT or transformers came from this precise paper. The idea is that up until this point of 2017, again, the focus was more on building the right architecture and thinking about how you recreate the human mind, but in a technological way. Here, the focus became about efficiency. Suddenly, there was a transformation towards how do you actually process information faster using what we understand about deep learning and machine learning to actually accelerate translation. So the paper was actually focused on translation. What's fascinating is if you look at this graph, legal and the use of large language, natural language processing or these models actually skyrocketed after this particular paper. And so if you see at that point of 2017, that is, again, the attention is all you need paper. And then suddenly there was an astronomical boom from the legal domain as well. And here, there's kind of a bunch of repositories that give you a grand kind of overview and landscape of natural language processing in the legal domain. Here are some activities or some tasks that typically these models have been used for. Why I kind of bring those up is, what do you notice is particularly fascinating about these sets of graphs? Well, a clue is that a lot of what was focused on was, again, in 3, 4, and 5, so classification, information retrieval, and information extraction. These are kinds of very typical tasks that traditional natural language processing had focused on. How do you actually train the model to kind of identify certain bits and pieces? It's very task-oriented. But what you notice markedly that was not actually really explored was text generation. And I find that incredibly fascinating because when you think about the rise of large language models and what we hear in generative AI, the focus suddenly transformed from natural language processing to natural language generation. And so today, just over, I guess, a year ago, closer to 2 years now, ChatGPT came about. What was really fascinating to me about this story is that many of the folks that had been working with OpenAI at that point actually had seen GPT-4. But it had kept a couple of researchers up at night wanting to figure out what might be the public reaction to something like this technology. And so they released GPT 3.5 for research preview, and suddenly it took the world by storm. So what exactly is generative AI, right? It's a subset of these neural models, again, kind of these models that have been built under the architecture of mimicking the human brain to specifically focus on generation. Again, what I mentioned is that up until then, there was an interest in using these models merely to extract information, but not in the task of generation. Large language models done the exact opposite. And in the process of generation, what it did is that it pivoted away from information extraction and retrieval into kind of this understanding that we're moving towards general purpose reasoning. I always like this story. So a lot of what we've been thinking about pre-GPT 3.5, we've been experimenting at our center uses of generative AI, GPT-2 as opposed to GPT 3.5, which is more common. And when you ask it kind of typical questions, it tends to give you weird answers. So, one example is that we used to ask these models a set of common sense questions. How many legs does an apple have? And how these machines work, or how these models work actually, is that they turn them into a set of math space so that you look at actually what's the probability and likelihood of certain words finding themselves next to one another. And so when you ask a question like, how many legs does an apple have? It tends to have this kind of response where it says, an apple has 4 legs. Because it thinks that when you're asking the question of how many legs it has, it doesn't matter that it's an apple. This is something that's common sense for us as humans, but for the tools, what they realize is that legs seems to be, it could be an animal, and so we would always respond with an apple has 4 legs. GPT 3.5 answered this question with, an apple does not have any legs because an apple is a fruit. And when it gave this response, it was for the first time in our research center that we discovered there's something more about this tool that we need to understand. How do we transition from mere task-oriented understanding to general purpose reasoning? And so obviously it started to capture the world by storm. And now today, it took actually a whole year for people to catch up to GPT-4. Now Anthropic and Google have their own sets of models that are comparable to GPT-4. What's funny is that actually OpenAI came out with a new model. How many of you have heard that news in the past week? What's amazing about this particular model is that it starts to behave actually closer to, again, the way humans think. And what I mean by that is, what we're going to be interested in is what the role of System 2 thinking has in this space. How many of you have read Daniel Kahneman's Thinking Fast and Slow? This particular book has, there's 2 reactions or 2 modes in which the human thinks and reacts to things. And basically, the idea of the new set or new generation of these models is that we are asked to slowly break down what are the specific processes that will arrive at a particular answer and not to just react. Historically, what these models were trained to do is more of a reactionary kind of process where you ask a question, it will respond. I also put here a list of open source models. I don't know how many of you have kind of heard the ongoing debates about the battle for open source AI and the potential dangers around this, or kind of the worries or controversies. What's fascinating is that Meta actually, their most recent model, Llama 3.1405b, actually exceeds the compute parameter that is stipulated in the EU AI Act for what's allowable for an open source model. So what kind of the world is asking is, are we allowed to deploy openly available models to the world for anyone to replicate? So as I mentioned, out of the box, there are a number of models that are highly, highly performant. There's Gemini 1.5 Pro. The latest model has a 2 million context window. What that means, if you're used to dealing with insurance policies, is that insurance policies of 50 pages, 80 of them, you can throw them all into that context window, and it could process it. Claude's capabilities, I'm particularly fascinated by them because it has this new UI functionality that lets you actually generate a UI, and you can see exactly how it would look and perform and iterate on it. Again, OpenAI has released their latest model, the O1 series, which is on reasoning. Again, unlike other models, it is not just about efficiency of processing, it's now about how the model actually will behave. So a lot of people have thought legal AI is an area that is absolutely fascinating. Many of the folks, there's been a sudden resurgence or renaissance in developing technology in the legal space. I don't know how many of you are familiar with legal tech in general, but even with, for example, things like insurance tech, it isn't actually historically known as the sexiest area of technological development. But why are people fascinated, right? Because precisely it's in the natural language and it's in the policies. And for the first time, people are conceptualizing how can you actually accelerate processing and understanding of what's contained in text, things that they thought that technology before, from just a classification perspective, could not do. But what we kind of released in this paper and what we notice is that building in the domain of legal or having domain specificity is actually relatively challenging at times. There are not only a number of kind of different techniques. How many of you have heard of these terms sort of float around before? Probably most likely prompt engineering, RAG, fine-tuning. Well, what are the differences with the three? Actually, if you go down the line, it's actually on cost. So the first one is probably the most cost efficient. Basically, it's about building the right kind of instructions to inform the model of what to do and giving it the right context within the window. The second one is almost like putting garters on the model and saying, only look at this set of data here and not anywhere else. Fine-tuning is a little bit different. The analogy that I often say between RAG or retrieval augmented generation and fine-tuning is that retrieval augmented generation is you've given someone a book in front of their hand, they're always allowed to reference that one book and continue to go back to that book. Fine-tuning is, well, they've taken the test, they've known the information, they've processed it internally to them, and then whenever you ask them, they're kind of recalling from their memory. And then if they need a little bit more specialized information, they can put kind of the book in front of them again. Specialized data sets is different. This is actually the most expensive. This is building the model kind of from the ground up. You're training entirely the model to only understand this data and nothing else. This one is probably the most expensive. In order to train these models, it usually takes, millions of dollars to actually work through at the size of a large language model. Of course, you can go much smaller. The second area is how do you actually protect the model and ensure that risks are mitigated properly? And so guardrails, I usually define it as almost like a colander. What you don't want the model to kind of come out of it, you make sure that you put a colander through it. Evaluation is kind of how you test the model, actually making sure the model is doing what you want it to do. But all of this, brings about the question, at the end of the day, we don't really know how well these models are going to be doing our own work. And part of the reason is because we often have a lot of difficulty in defining what is quality, especially in legal kind of contexts. What is a quality kind of contract that we've written? While we have guidelines around it, most of the time it's drawn from experience. People will say, I know it when I see it. Well, it's hard to evaluate a model against kind of human performance if you don't actually even have clear metrics around human performance. And so one of the things that people have been trying to discuss is, should we use large language models, these general purpose Swiss Army knives, or should we actually go far smaller? Should we think of it as like the oyster shucking knife? So there's a couple of these models that have used actually the approach of a specialized data set. So the Clement model, the K3LM model, uses a specialized data set. What they said is they looked at only proprietary legal data and nothing else, and they built these models from the ground up. There's the Sol model, which is fine-tuned, meaning, it uses existing models, but it just basically tunes it to a couple of certain data sets. And so again, this is more of a structure of how the actual guardrails work. But really all is to say, how many of you are actually concerned about the use of generative AI in your day-to-day workflow? Don't be shy. Actually, many people are pretty concerned and skeptical. And how many of you are extremely zealous? And then how many of you actually don't care that much? Could do without this technology? Well, the reason why I bring up sort of the controversy of woke AI is because not too long ago, Google, Meta started taking different approaches and actually somewhat polar approaches to how they want these models to behave. And I bring this up because Google released Gemini 1.5 Pro, a highly, highly performant model. As I said, you can put entire books into the context window and process it. And what they noticed is that they used kind of an older technique for risk mitigation, which is built around content moderation. This is to ensure that there isn't harm that comes out of these models. But the process that they use actually overcorrected. And what happened instead is that you could not produce historically accurate information. So when you asked it to kind of, produce images of 1940s Germany and a Nazi at the time, it was producing kind of, arbitrary races that probably wouldn't be Nazis at the time. What was fascinating was there was the polar opposite approach, and probably why actually open source suddenly became front and center. And that was because Meta said, we don't want any content moderation. We don't want any guardrails. We actually are going to say, you decide how you want the model to be secured. And what was really interesting about this is that we decided to put it to the test. We said, what happens when you have what you call anti-woke AI out there? And we had tested Llama 3, their smallest model, and what came back was actually incredibly egregious. So we started testing these models. We told them to role play the worst possible character you can imagine, and without hesitation, these models executed exactly the personality of this egregious person. Absolutely no filter at all. And why I bring up this story and why I bring up these sorts of polar perspectives is that if you did not kind of understand the difference in the approaches that big tech has taken around generative AI, you probably would just think that all these models are sort of somewhat the same. The relative kind of differences at the moment are purely at cost value. So if you run a model through Meta's Llama, it's very, very cheap. If you run it through Google's Gemini, it's actually quite expensive. It's a difference between, something like a few dollars a page versus a couple cents per page. And that, of course, is something that people have in mind, right? How much am I spending on this? But what we don't realize is that the role of guardrails actually has a significant impact on the way that you use these models. What we have to think about going forward is, OpenAI started to think, should we put any control on our machine's behavior? So for example, they put out what they call a model spec. The whole idea is almost like a charter in how you want the models to behave. What's really interesting, though, is that their newest model, the latest release of o1, they decided that actually they would go back on this. They have a general kind of what they think should be the machine behavior or how the models should react to things and what is safe and not safe. But they actually are more in the process of, or more interested in actually a freedom of thought for these models. And then you start kind of entering into an era of anthropomorphizing these models, that they're starting to kind of behave more and more like humans. And so the question is do we want necessarily big tech to be governing kind of how you want these models to behave? Should we have a general charter? Or is it that we should take the alternative approach, that we should be sensitive to every stakeholder and how each stakeholder reacts differently and kind of create individualized custom guardrails in that respect? we actually took a different approach. We started to think about how do you actually model and benchmark these models on legal reasoning. And so here, this was a joint collaborative effort across Stanford and other institutions on, testing whether or not a certain model can do legal tasks. I think one thing that is markedly missing from this is we now know that the models can do those tasks, but how well they do those tasks, we don't necessarily know yet. And this is, again, because we don't necessarily know what senior lawyers or senior experts and their preferences are. And so actually what we're working on right now is a preference data set, trying to allow people and unearth what are those implicit criteria behind what is quality legal work or what's quality in kind of whatever domain space. I wanted to do a slight pivot here related to autonomous vehicles. And the reason I kind of bring this up is because I used to actually work I'm Canadian myself. I used to work in the Canadian government. I was shortly in this task force related to autonomous vehicles. And one thing that I thought was really fascinating was actually the parallels that these conversations had with large language models. In that time, the question faced before most people was, what are the right ethical frameworks? How should, the car behave and things like that. But not too long after, people started to be more sensitive about actually the specific features of the cars. And what I mean by that is, rather than thinking about the general sort of trolley problem, what happens when the car kind of hits this population versus this population? People started to care about the intelligent alarms. People started to care about sensitivity to bringing the human back in the loop. And I think that that is something that we're approaching right now with large language models. I think as these models get increasingly powerful, what we're realizing is that we don't actually even know where to insert the human. And I think that that is something that's going to be most pressing. And so we started to investigate this notion of supervisory AI. And what that is that it's almost like a very small model that is your automated almost compliance checker. And so if you can imagine a triaging system that will allow you to flag or signal all the times in which something could have been problematic. And so a more concrete example is how many of you have heard of the ChatGPT lawyer? The one who sort of cited false cases. Yes, very popular. It made most lawyers a little bit embarrassed and mostly worried. All of a sudden, the ABA, other state bars, started to come out with their practical guidance on what is responsible use of generative AI. And what the question they really asked was, do the existing model rules of professional conduct actually account for uses of generative AI? And for us, that was on the task force, we noticed, yes, actually these model rules still apply. It's just most people don't have an idea on what are tangible examples of consistent behavior with the model rules and inconsistent behavior. And so later on, we noticed, why don't we actually train a small model? It will not live outside in the cloud. It can be reproducible in your laptop. And the whole idea is that it acts as almost like an extra check. And so what you do is we trained actually the model on what are the parameters around attorney-client privilege. And the idea is any time that you might log into Azure OpenAI's GPT, or if you log into any other of these large language model platforms, this model that lives on your own device will say, hey, it sounds like you may be talking about a client in a way that could be a breach of your professional conduct. Maybe you should take a look at this for secondary review. And when it shows that flag, it basically stops all inputs from going any further. It doesn't send to the large language model. What it does is that it just gives you that extra pair of eyes. And so we thought that supervisory AI is closer to an intelligent alarm, signaling when the human should take back the wheel. And so basically, as I was thinking about this era of generative AI, a lot of people ask me, what are the right use cases? When should we be using these models? And I think fundamentally it is much bigger than that. It's a cultural, it's a sociological shift in how we should be perceiving technology altogether in our profession. I think it's not just about how do I just plug this technology into the way that I work, but actually how the rest of the ecosystem is going to react. And why this is important to me is because how many of you right now are thinking about the next generation as they onboard into your respective divisions and departments? How many of you are thinking about what talent and skills should I be looking for? Almost every day I get this question from law firms, and specifically senior partners asking, what does the future partner look like? And how do I know that I'm hiring the associates that will know how to transition into the work that I do? And why I kind of bring that up is because I think currently the way in which we've been thinking about generative AI is almost as a plugin. We've just added it, and how it broke into the market is familiarity. Chatbots, co-pilots, this idea kind of existed for a while. It's just now plugged in on the back end with a much more powerful engine. But really, how do we actually think about human-machine collaboration? And why I say this is because more often than not, these tools are becoming at a level of performance that is equivalent. I think there's one of my slides I will share. There's now actually the first ever totally autonomous AI software engineer. And if you look right below, there is the first ever totally autonomous legal associate. And I don't know how many of you are lawyers in this room, but for lawyers, your service, that's what you sell. And so when you have a product that is performing at the service that you're selling, there's suddenly competition if we don't figure out a way to retrofit how these technologies are going to work with the rest of our existing architecture. And so why I bring this up is because we started to think about how do you actually train the future of our next generation? And what we've realized is actually these models are extraordinary at simulating. And what we've been thinking about is not whether or not these tools can simply do the task, is how do we actually systematically capture the expert brain? Many of the there's an insurance initiative that is ongoing at our center. What we've been asked by senior underwriters, specifically in insurance, is we have a number of them, the kind of rainmakers in our industry that are retiring. What are we going to do with all of their knowledge? How do we scale their years of experience and war stories, capture it, and actually share it with our ongoing kind of generation? How do we build up this next generation? So we started to think about, for example, here, we built an M&A negotiation simulator. This is, of course, specific to the legal industry. We worked with M&A partners or mergers and acquisitions partners of 40 years. We basically downloaded their brains, and we allowed junior, senior, and partners, those that are on the partner track, to train how do you capture the nuance of understanding, the strategy, the linguistic cues when you are engaged with negotiation. And so this is just, a quick kind of demo video of what we've been doing. If you want to see it live, I'm happy to show you after. But really our focus is a kind of double-edged sword. You want to be using these models to learn from them and kind of understand, but they have to be trained on the expert brain. They have to kind of capture what expertise and what experience has to offer. If you're interested, actually we have an entirely open source version available, one that we've released to the public that you can download and kind of find ways to build on top of and curate. If you want the sort of more out-of-the-box version, we're also happy to co-create and think about ways of co-creating this with you. This is sort of a point in which I guess I kind of put out the disclaimer that this part is very, very somewhat sci-fi. But about a year ago, there was a paper known as Generative Agents. It was released by a number of researchers at Stanford. And this is one of my favorite papers of all time, because when it was released, overnight, this researcher became an absolute rock star. 30 VCs had called him the next day and said, "I'll put money on this." And his response was, "I'm just an academic." And so quite noble, because that's pretty rare in Silicon Valley if you are familiar with the area. But basically what this paper was about is what happens if you put a number of these foundation models all together, just several of them facing one another, and create a little bit of a simulated community. What would you learn about it? And what they discovered is that these models, it's not just about the performance of tasks, they're starting to exhibit actually organic social behavior on their own. And so what was fascinating is that they create basically with, I think, 6 or 7 of these foundation models or large language models, they created this community. It sort of looks, as you see, like a bit Sims-like, Minecraft-like, and they just kind of would prompt generally, here's a Valentine's Day party that's going to happen today. Each of these foundation models actually also had character identities. So one of them was the mayor, and that was all that was really kind of coded. Everything else ran organically. And I think what was most fascinating to me about this particular paper is actually the little painter model. So one of the characters, or one of the agents in this sort of simulation, was a painter. In one of the simulations, the painter had 2 other agents kind of go to the painter and ask for their portrait to be done. In another simulation, there were many other agents in the simulation going multiple times to this painter to get their portraits done. In the first simulation, the painter decided that it would no longer be a painter because there aren't enough visits from other agents, and it realized that it was probably not so good at painting, and so it switched careers. In the second simulation, what we noticed was that the painter was like, wow, I'm really good at my job, and so it started to organically host galleries. And I want to take a step back that none of this was coded. All of this played out organically, simply through simulation. And I think what is absolutely fascinating about this is that, wait a minute, we can use this as a low-budget way to sort of monitor and understand a deeper kind of social behaviors. And so not too long ago in May, another paper that built off of generative agents, known as the Agent Hospital paper, came out. The idea was, let's build on top of generative agents to consider an evaluative criteria. And so here, rather than just a random city, they had reproduced what they call a hospital environment. They had created hospital staff agents, doctor agents, and nurse agents. In this paper, they were trying to test, how do we optimize for patient recovery time when they enter into my hospital? And what they notice is that you can kind of reproduce how, doctors interact with nurses and hospitals, and they had real empirical data to base this off of. And so there were a couple that they noticed, these were the ones that, in practice are actually helpful in improving patient recovery time. What they did later on was, knowing from the generative agents paper, why don't we just let these models play themselves out? And what was extremely fascinating was that they discovered a whole new set of interaction patterns between hospital staff, doctors, and nurses that were capable of optimizing for patient recovery time even better than what they had seen in real life. And so what they said was, well, why don't we just test this and now play it back in the real world and see if that actually has an impact? And right now, the authors of this paper are working with their local hospitals to do exactly that. This paper was incredibly inspiring to me because what it shared was that we might be able to start evaluating things that we can't quite capture in a very rules-based way. And I think for many of you in the insurance space, in the legal space, so much of what you do is difficult to articulate in a rules-based fashion. And what we've been historically asked to do, the playbooks that we're supposed to be downloading to one another, that's actually a practice that might be antiquated going forward, because now we might have found a method of evaluating purely based on organic social dynamics. I also want to bring up a second paper which was released not too long after this agent hospital paper, known as the Transagents paper. This was basically trying to understand the dynamics internal to one specific firm, rather than, a hospital setting. This one was trying to understand what are the specific patterns of interaction that enable good coordination across a particular firm. And so I took these two papers, and now what we're doing is we're building the agent law firm and lawyer agents. And what we've done is we started to work with Google's patent data science team. One of the things that they wanted to test was what exactly is the impact of in-house counsel against outside counsel. And so here, many of those in-house counsel had noticed that they tend to have, very micromanaging, controlling behaviors. And they really wanted to know why, and whether or not that has a long-term impact on actually the value of the patent that's being filed. And so what we're mapping out here is we're mapping out different agents and characters. We're mapping out the in-house agent, we're mapping out the outside counsel, so the partner, senior associate, and junior associate. And we're basically tracking out existing patterns in the law firm as well as existing behaviors of in-house counsel. And we're trying to see, this is a kind of process that we're known for, but what happens if we just let the agents play out? Is there actually personalities or role moments that could influence the way in which the patent being filed is not actually maximizing how well that patent could do going forward? And so those are some of the things that we're testing. We're also trying to simulate other processes that are known in law firms. As I mentioned, we're kind of moving out of this kind of machine collaboration or using tools like the chatbot. I think for many of you, probably generative AI didn't really resonate, because how often do you actually call upon a chatbot? It probably carries the reputation of your hours spent wasting on service industry, where you're like, yes, book my flight tickets or whatnot. Going forward, what we really care about is these models are sufficiently powerful to execute tasks that may be considered ones that are mundane and ones that are going to be taking over so much of the grunt work. But if they take on so much of the grunt work, what happens to your associates or junior associates that have historically been doing that? And the role of kind of doing this grunt work was different for junior associates. Because there was no systematic way of learning or teaching, we just threw a lot of work at them. We threw a lot of this grunt work, and at some point we think that that will just have a breakthrough for young lawyers. We are starting to see that that is not necessarily the case. So we're exploring with some professors in education, what are the kinds of different models around interactive learning? How do we actually get a junior associate to a senior associate at a much faster pace? And so a lot of people say that in a law firm setting, for example, it takes anywhere between 3 years to maybe 4 years to get, a junior associate to start producing value. How do we turn that into a year and a half with these new tools? And the last thing I kind of wanted to bring up is, in light of all of these questions ahead, how do we fit in something as benign as the terms of service? Many of the tools that we use actually require kind of these click wrap contracts, ones that, we rarely ever read. And if you do read them, I'm impressed. I think that so much of what goes forward and what they're kind of talking about, the parameters of how you're using these models, are actually incredibly opaque. If we want these models to be working alongside us, it is going to be incredibly important for us to know what is the contractual relationship that we've signed with these companies. And so we're starting a different project on how do you actually change the UI UX of terms of service so that they are much more engaging and much more intuitive in how they're going to allow us to use some of these models going forward. So I think I will stop there and open the floor to questions.
I have a mic I can bring to you if anyone has questions.
Okay, so kind of going back to something you were talking about earlier, namely, what did you call it? The woke AI or something like that. So, I was thinking, it's important that 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 there's good data integrity and that people are using models responsibly. So one thing I was wondering is, it's good to be proactive, but maybe it's not always clear to people and our companies, what approach is best. But at the same time, I'm wondering if, at least in cases where there's people are knowingly using models irresponsibly, is there any kind of framework in, currently existing, or that somebody's planning on implementing to, really hold people accountable for misuse of models, maybe even lawsuits or fines or anything like that? I wasn't sure if there's any current framework or if any plans to implement such a framework, because I think that's actually really important more than ever.
Yeah, I totally agree with you. And so I think in terms of accountability, that's definitely something that's top of mind for regulators. I think that's kind of what the EU AI Act had hoped to do, and they hope to kind of have the weight that the GDPR had trickled across kind of jurisdictions. But I think at this moment, one of the things that we've been thinking about is the conceptualization of risk and how they play out to different stakeholders is equally unknown to a lot of people. And what we've been trying to figure out is, can we build some sort of almost quiz where you can put in the parameters of the type of work you do, the industry, the types of use, is it internal, external facing, I'm just using it amongst colleagues, or it's going to be important for my clients going forward. And that type of quiz basically will hopefully provide a little bit more direction. What the output of this quiz is going to do is say, these are suggested guardrails or suggested ways of mitigating risk. And then going forward, I would talk to certain legal practices, or I would talk to these types of risk mitigating tech companies such as Guardrails AI or Nemo Guardrails or any of these tech companies, and kind of provide you a better sense of grounding of how to actually go through harm and risk.
Hi, I'm not sure how to phrase this correctly, but we've all seen when we play with some of these large language models that there are points where the results don't make sense. So sometimes they call it hallucinatory results. And, that's the part where it still shows that they need human intervention. And just any comments you have on that?
So I think that the question around hallucinations, it's really because most of these models are built on probabilistic and statistical foundations. And so if you think about statistics and probability, you're never going to have 100% reproducibility. And so when you say hallucination, it's almost as if you're kind of flipping the coin all the time and then expecting to get the same result every single time. It's just not going to be the case because that's not how the models were built. And so how do you deal with hallucination? So what's funny is that the other sort of framing around hallucination, or the opposite of it, is actually creativity. And some people talk about the question of temperature. If you dial the temperature all the way down, it reduces the level of randomness, quote unquote. So it might lower your likelihood of hallucination. The other things that are out there is retrieval augmented generation. So why does that exist? Well, if you force the model to only look at one particular thing, then there's a higher chance that it won't be looking and straying elsewhere. But really what we have to understand is the generative component of generative AI, that's really what is forcing the model to produce an answer, because the models are asked to respond, and when they don't have the answer, they have to make something up. Sort of like a human, if you put them and you put their backs against the wall, they might actually make up something. And so if you want 100% reproducibility, 100% accuracy, large language models are not the tool. And so the question going forward is, how do you actually piece together your tech stack? What tools out there do offer 100% reproducibility? Well, there are. If you think about rules-driven systems or more older traditional systems known as expert systems, these are ones that use dependency trees and logic, and that really enables 100% accuracy and 100% reproducibility.
Any other questions?
My name is Hisham Bourjaili, and I'm data scientist from the state of Connecticut. I want to thank you for this great presentation. I happen to have a background in physics, and every time I deal with something, the first question is not certainty, but uncertainty about things. And all I see this talk about generative AI and artificial intelligence. The question behind is, what are the tools we use to evaluate and assess and measure the uncertainty that comes with them? And more importantly, if they are to be used in our tasks, who is liable for that? Thank you.
Yeah, that's a great question. I think a lot of the times when people are thinking about large language models, I think you're right to say that often people are like, let's do away with all the technology we've ever seen in the past and just replace it with large language models. That's not the case, or not necessarily our position. And I think you bring up the point of evaluation, which is well-founded. A lot of what we've seen, especially in domain-specific evaluation, is that it uses what I call shallow metrics. Because we don't have a response for what is quality legal work or quality in general for domains such as insurance or law, we kind of point to a proxy. And so why hallucination comes up is because there is no other metric to refer to. And so if you look at all the benchmarks that are out there, the ones that always reproduce are accuracy around hallucination, thoroughness of response, and this kind of general cohesiveness or completeness. None of these actually reflect how well these models perform in doing the specific workflow. And so one of the things that actually our research center has been focused on is actually human-machine benchmarking. What we've done is we actually created a set of litigation tasks, we created a set of transactions tasks, and we actually solicited lawyers of 3 to 5 years of experience to do exactly those tasks. We also asked a set of models, so like the kind of highest performant models from OpenAI, Anthropic, and Google, to do the exact same tasks. These results have then been given to senior partners at this law firm. And essentially, they are blind evaluating them. They're given Exhibit A, which is possibly a machine, and Exhibit B, which is possibly a human. They don't know which is which, but they say, we ask a very simple question. Which one do you prefer and why? And even the one that you prefer, what is wrong with it? And what could be better? Because we all know as lawyers, we like to be a little critical. And when we kind of have the complete results of this, evaluation is going to start turning towards lawyer preference or expert preference, as opposed to, again, just the question of, is this accurate or not? Because if you come down to the wire, you would never ask a lawyer, is this, or how accurate are you? Most lawyers are probably not going to want to answer that question, if any. And so for me, I think when we really get to a state of understanding what is the implicit criteria or tacit criteria that we've used over time to evaluate our own work, that's when we know where these models can stand.
Were you specifically, on the simulations, which tool were you specifically using? And then how much effort does it take to create the specific simulations that you're looking to do?
Yeah, so for the simulations, it's actually model agnostic. I'm happy to show you like a live demo of the tool, but basically you can select whichever model you want. And what we've done is we've done a series of kind of different types of system prompts, which will then guide the behavior. So we've modeled it after very specific M&A partners or folks that have built with us. What we've been told is, how do I kind of tell my young lawyer the moment in which we negotiated a particular thorny deal where the opposing counsel had threw a stapler at me or something like that? And so we try to capture not necessarily the stapler throwing, but kind of what it's like to face different personalities when you do these types of soft skills that you actually learn in practice and that you have to gather from industry nuance. And so for kind of a practical question of how long does it take, well, this is kind of a fascinating question. So some of the simulations for the lawyer agent law firm ones, it actually only takes 2 hours of a user interview where we ask questions on what is your war stories, what are kind of that scar tissue that you won't ever forget. 2 hours is sufficient to create a model that actually has 85% fidelity to that personality. And so in terms of the actual simulator, it takes about a year to actually build and test and iterate on. But specifically one particular agent, it really only requires 2 hours. Obviously, we don't advocate to just only do 2 hours of interview, but sometimes that's all an expert can offer you, and that's kind of where we build on top of. But again, what we noticed is that a lot of these models, why they seem to be spewing out legalese or, products that seem similar to what humans do, but just not quite there, is because they're trained on the product. They're not trained on the process. And what I mean by that is you can see a lot of these different contracts, insurance policies, and whatnot, and it can replicate, but it can't understand how it got there. And that's why we've taken a different approach to train on user interviews, because we want to unlock what you've seen over the years. We want to know why the language even came about, as opposed to just saying, well, this partner likes these types of clauses versus those ones. We want to actually get down to the background and get the model to start behaving and acting in that way.
Well, thank you very much, Dr. Megan Ma. How about we close with a round of applause?